Alright, this is my custom built CNC needle cutter, which I've named the Gateway Foam Board CNC, or just the FBCNC for short. Its main purpose is to cut out RC plane parts with a lot more accuracy than I could just cutting them out by hand. In the past, I've spent hours and hours just cutting out flight test plans or my own designs by hand, and it just takes forever. And so I built this thing just to cut these parts out for me, which saves a lot of time and effort, and again, it's a lot more accurate than it would be just cutting them out by hand. It took a lot of time engineering and designing and reprinting parts to get this thing to work, but eventually I've somewhat got a working machine. It still makes a lot of mistakes and stuff, but I'm pretty happy with it right now, and I'm going to show you how it works. So the first step in designing and cutting out these planes is actually designing the planes, or just getting them from a file online somewhere. So to design my planes, I use Onshape. It's just what I'm most familiar with, and I can kind of make pretty good designs in there. I'm still looking for a good 2D CAD, but Onshape is my best bet for right now. So after you've designed them, you just click, there's an export DXF option in here. It should show it right here. And that's what I do, just export it as DXF, and then you send it over to this software right here. This software is called MillMage. It's the best software that I've found so far, and I've tried a lot of different softwares. All the other ones that I've tried, like CNCJS, a bunch of other G-code senders, they were just really clunky and hard to work with. But yeah, this one's the best. Then what I did with the DXF files, I bought in all the parts and arranged them, made them all fit onto the foam board size, and then with these blue lines and the black lines, the blue lines correspond to a score cut, so it means just going halfway down into the foam, and the black lines are full cut, and I programmed them to work like that. And then right here you can see me just putting the foam board into the clips. I designed these clips so it kind of holds it down pretty well. Alright, here it is starting up a cut. I just turned on the machine by twisting the servo tester knob up there. It'll give you a few warnings, usually when starting it. I don't know why it does that. It's kind of usually not necessary. But here it is going. It moves pretty slow. I haven't really figured out how to make it move a little bit faster. But as of right now, it kind of completes the job in like 40 minutes, which is, I guess that's good enough. It's better than cutting them out by hand. But in the future, I do want to try to make it a little bit faster. Talking specifically about the needle cutter assembly, it's just a basic Thingiverse design that I found somewhere. There's a bunch of these designs on the internet everywhere. It's powered by an RC plane motor, just like you would find on any other RC plane, and that is controlled by a servo tester. That's what most designs on the internet had. Down at the bottom there, you can see there's about 4 mini bearings right there. Those are just to keep the needle going in straight. They help out. And then on the bottom, the very tip, that's an air screw needle. Those things kind of suck. I think I've gone through one of them already. They just wear out pretty fast. So if you were doing this, I would use a MIG welding tip. Those, I think, are going to be a lot better for this. They won't wear out as fast. I have a couple packs to try it out soon once this needle screws up at some point. But yeah, go for the MIG welding tip. It'll probably be a lot better. Onto the hardware that's controlling this machine. It's just a basic CNC shield stuck on top of an Arduino running Gerbil. I had a pretty tough time getting Gerbil on here, so just be warned about that. But yeah. Another part about this machine's programming via MillMage is that I have it designed or programmed to go through a score cut and then go through a full cut. A score cutting, like I said earlier, is just where the needle punctures the top layer of the paper. Score cutting is very necessary in basically every flight test design and almost every other foam board plane designs. That's just because you get a lot cleaner of a build, and everything seems to go a lot better with them. And so it was absolutely a must for when I was choosing a CNC software that could actually do this, because it's pretty tricky to find one. And after a while, I finally found MillMage. It took a lot of searching, but the reason I went with them is because they have a feature called layers. And what layers allows you to do is that you can assign different Z depths to different layers. So you saw that I had the black lines and the blue lines, so I could set the blue lines to like a depth of negative 0.5 millimeters or something like that. And then the black lines would probably be around like negative 4 millimeters or something. But yeah, MillMage is great. They allow me to do score cuts pretty accurately and stuff. Couldn't really find any other G-code sender that would do this pretty well. All of them were pretty clunky, and yeah, MillMage is good. This is the Long Easy when it's fully cut out. It turned out pretty good. There's a few problems with it. So right here, I think somehow near the end of the cut, the machine shifted over. I don't know how. I think it was probably like the belt system. I need to make a better cable carrier system for it. So that's a future upgrade. But for the most part, this machine's working out great. I'm building a lot of flight test planes and a lot of my own designs. And yeah, I'm just super happy that finally I've gotten this thing to work. It's taken a long time, but yeah. Down in this description, I'll have a few links to some YouTube videos that I used to help me build this machine. And yeah, thanks for watching this video, and enjoy this flight footage of the Long Easy. All right.
Yeah!
Ready?
Yeah! Can't see it like at all.
Woohoo!
I literally can't see it. I think it's coming towards us. Oh, it's right there. Oh, hit the ground.